All right, so I've got a stack of patterns that are used in Advent of Tess this year. And if you're not familiar with Advent of Tess, it's a series of patterns that I teach in December. It's a different set of patterns every year. And I've also got a stack of grids. And we're going to go through and practice each of the twists that are found in this year's Advent of Tess patterns. And this is so if you haven't folded these twists before, so you can have a model that you can then refer to, see how it works, see how the standing form is different from the squashed form, and get all of that in your head while you're folding these nice patterns. So first up is the closed triangle twist. And in this stack, mostly I have grids with 8 divisions. Later on in the stack, I have some with 12 divisions, and we might even need some with 16 divisions. We'll see when we get there. So for the closed triangle twist, I'm using a grid with 8 divisions. And the key thing with this twist is that there are 3 directions of mountain folds, and they meet at a single point. So these 3 directions of mountain folds, I always draw mountain folds in red, valley folds in blue. They are going to be rotating one way or the other around the paper, around the central point. And so the valley folds will either be, if the mountain's going out to the right-hand corner, they'll either be above or below. And if they're above, that makes a right-handed twist. If they're below, that makes a left-handed twist. And you'll see both of these twists, both the right and left-handed forms, in each of the patterns. Well, I should say most of the patterns where this twist shows up, it'll show up in both right and left-handed forms. There are some cases where you'll only see one or the other. And to squash this twist, we want to move our fingers in along these mountain folds until they're just outside of where the valley fold of one direction hits the mountain fold of the next. We're going to press on all 3 of those at the same time, and the paper will start to flatten in the middle, and then we can press from the top to continue flattening our twist. And by the way, if you have any questions, I can see the chat for this stream, and feel free to write in and share any questions that you have. So then I use my bone folder to make it nice and flat. That is the only twist used in day 1 of Advent of Tess. For day 2, I'm adding in an open triangle twist. So the open triangle twist, I'll grab another grid with 8 divisions, also has 3 mountain folds, but instead of them all coming to a single point, they're going to outline a single grid triangle. And in this one, we can't switch back and forth between the right and left-handed versions with the same mountain folds. If you see these mountain folds, then it's going to be a right-handed twist, and the valley folds are going to be out here. So notice that the valleys are further away from the outlined triangle on all 3 of these pleats. The valleys never touch the corner. So if the valley was on the other side of this mountain, it would touch the corner of the outlined triangle. That is the characteristic setup for a cursed triangle twist, and we're not doing any of those because we're not having any patterns in the series that require pre-creasing beyond the grid. So in setting up this twist, we set up those mountain folds, we lay them down over the valley folds, and just like we did for the closed triangle, we're going to press on each pleat just outside of where the valley of one direction hits the mountain of the next. So just outside those intersections. We want to make sure that these new folds that are forming are the only ones that are not on grid lines. With that in place, we can go ahead and press to squash. The left-handed form would be set up in the opposite rotational sense, and we can actually see the left-handed form with these same folds. We just need to switch all the mountains to valleys and all the valleys to mountains. And when we do, we will see the open triangle hole on this side and a left-handed open triangle twist on the other side. This move works for all twists. If you want to see a right-handed version and a left-handed version using the same folds on the same paper, you can convert all the mountains to valleys, all the valleys to mountains, and that will change the twist from right to left-handed or vice versa. One interesting thing about these open twists is that what you outline with the mountain folds is exactly the same as the hole you get on the back. It applies not just to triangles, but to other shapes as well. And speaking of that hole, our next twist shows up in day 3, which is a double open triangle twist. Notice this triangle hole is a lot bigger than that one there, and that's because it has 2 grid spacings per edge instead of 1. So I'm going to grab another of my 8 division grids, and I'm going to draw out with mountain folds what that central triangle is going to look like. And I'm going to apparently use my other red pen because that one is running out of ink. So I'm keeping it fairly close to the center just for purposes of folding. My center point on this grid is right here, just if you want to copy this exactly. And then to make this a right-handed twist, I'm going to extend the mountains selectively from the corners of the twist so that my valley is above if the mountain is going horizontally out to the right. So this one is harder to confuse where the valleys go. Actually, that grid line is there. Because if the valley was on the other side, it would be running right into the middle of that giant open triangle. And we can set this up just like the other 2 triangle twists and press to squash. One thing I haven't mentioned yet is just how many twists are in Advent of Tess this year. But before I quite get to that, you might notice that this time, when I started pressing, some of the corners showed up before others, and I was emphasizing each corner individually before getting all of the edges more firmly folded and using my bone folder to squash the rest of the way. That's because there are smaller angles between, I'll use a cleaner example, between our new fold and the valley fold than there were for the open twist or the closed twist. So these twists are going to be a little bit more fussy at the corners, but still very reasonable to fold. So as far as number of twists, there's going to be 4 different triangle twists, 5 different hexagon twists without using any hybrid hexagon twists. There's going to be 2, actually technically 3 different rhombus twists, 2 trapezoid twists. I think that rounds out the total number. So we've got 3 of our triangles, the closed, the open, and the double open, which you can see on the back has that 2 grid spacing per edge hole, which looks a lot bigger, a lot more than twice the size of the single open hole because it's 4 times the area. And now we can move into the next twist that'll be showing up. The Day 4 of Advent of Tess pattern uses only open triangle twists, so that's a bit of a reprieve in terms of the twists used, but it uses them on both sides of the paper, so that's a step up in difficulty. Then for Day 5, we introduce closed hexagon twists. So I'll do this one with another 8 division grid. With the closed hexagon, like the closed triangle, all of the mountain folds will be coming to a single point. And this time there will be 6 of them. And our valley folds are going to be 1 space away. I'm doing this one right-handed. All of the regular hexagon twists are going to be right-handed, but there might be some other things going on in later days with some mixed depth hexagons. The key thing with the closed hexagon that is different from some of the other twists, in particular different from other closed twists, is that the eventual twist has, I'm going to do this kind of roughed in, has all of its eventual folds on grid lines. So those are the eventual folds of the twist minus these extensions of the mountain folds coming in. And we're going to respect those folds instead of having like a spiral that would have tension between here. So we're going to respect the central hexagon as we pull this together. And this is something that's going to be actually easier to put into place on a larger grid because the pleats are actually going to stay in place and you can have them on the table. In this case, we could have 1 grid spacing worth of pleat that stays put on the table, but that's going to be a slightly harder way to get this folded. It is the way that I'll show in the tutorials for Advent of Tess, but for right now, what I want us to do is pinch this mountain, then come up right to the corner and let that fold closed. Then come to the next mountain and pinch it at the corner of that hexagon and let it fold closed. And the next one, and the next one. And we're letting things be very 3D under here, but with the next two corners, we can get that into place. Now that's a technique that's easiest on this size of grid. And it makes a very pretty little star. But I emphasize on this size of grid because the technique to get it folded is going to be slightly different when you have access to longer pleats that can lay flat on the table. This is a case that once it's folded, it really does not want to be unfolded. Unlike the closed triangle, this one is really firmly in place. But like the closed triangle, all of the folds are coming around a single point on the back. What you outline in the front, in this case a single point for the closed twists, is what you get on the back. Continuing along with the Advent of Tess patterns, the next day has another hexagon twist on the front. This is an open hexagon twist. It also has closed hexagons on the back. But this open hexagon twist, I'm going to use a larger grid to fold, not larger in terms of size of the paper, but more spacings. This one has 12 spacings, 16 would also be perfectly fine. For the open hexagon twist, I'm going to find the center of the paper, and then all of my mountain folds for this twist are going to be one space away from the center. And one of the cool things about this twist is that what shows up when you set it up is actually a star. And you have the same folds that get squashed whether you squash it right-handed or left-handed. So I'm showing the right-handed case where the mountain folds are shifted up on the right-hand side. And then the valleys are going to be one space further out. But you could also take the mirror image of this. You'd end up with the same folds between the points of the star. So to fold this twist, I'm going to pinch the mountain, and if I want to do this without drawing, it would be the mountain that hits the corner, one space above the corner, and the valley above that. I'm going to pass that plate to my left hand, then repeat with the next corner, putting in the mountain and the valley, pass it to my left, put in the next pleat and the next. And with this star drawn on here, it's pretty straightforward to see how far our mountain and valley folds should be going. But without the star, you could have easily extended this first mountain and valley past the center. That's the common error mode for this twist. And so the fourth and fifth pleats, I generally emphasize the mountains at the same time and then gradually get the valleys into place. Now this twist is the easiest one to squash. You press from the top and just boom, like a button, it shows up, and we can use the bone folder to press the rest. So as long as your pleats are happy, then this twist, you just bop it and it goes into place. Flipping over, I've got my open hexagon hole, just like I outlined in mountain folds on the front. So we've got our closed and open hexagon. The next twist to show up is the closed rhombus. So this is a closed hexagon on front, an open triangle on the back, and then the closed rhombus. This one I'm going to use a 8 division grid to fold. So one of the key features of the closed rhombus is there is a mountain fold from one side that continues straight through to the other side. I'm just going to move that dead pen further away from me so I stop hoping that it suddenly starts working better. And then, so this is what I call the through line of the twist. And then there is a central diamond, 2 grid triangles on opposite sides of the through line. And how the diagonals come off of this central diamond, whether they're going this way or this way, is what determines whether this is a right or a left-handed twist. Because our valley folds need to be further away from whatever central area we're working on than the mountain folds. And then for the through line, we follow the direction set by those diagonals. For our closed rhombus twist, we'll start setting up those mountain folds and then lay them down on the valley folds. To get our rhombus twist. And this one is just about as easy as the open hexagon to squash. You can see it has that same kind of edge on both sides as the hexagon star. Like if I hide part of this, that in, out is exactly what we see here. And I'll press from the top. So put my finger on top. And if the pleats are solidly in place, then pressing from the top won't move anything else. It'll just squash the twist. From there, in Advent of Tess, we have a pattern that uses both right and left-handed rhombus twists, with the left-handed ones on the front of the paper and the right-handed ones on the back. And then we get several patterns that use both right and left-handed closed triangle and closed rhombus twists. Oh, I didn't show yet the back of this twist. It makes a slit. And so all of these slits here are closed rhombus twists on the other side. I will say that you won't always see a slit when there's a closed rhombus on the other side if the next twist is close enough in that it's stealing paper away from the slit, making these little 30, 60, 90 right triangles. And we have a couple days of really dense patterns of closed rhombus and closed triangle twists before we start adding any new twists. So this twist might look like a closed rhombus, but you'll notice that there's that little leg, which if I did it here, I would have to change the direction on that pleat and make this in double depth. So this is not a closed rhombus. Closed rhombus was out here. This is a closed trapezoid. So the closed trapezoid I'll do again on an 8 division grid. And I'm going to have 3 directions that meet at the center and make a crow's foot. So these are the 3 directions from the closed triangle twist, and then also another pleat. And you can think of it like adding another grid spacing of contraction through the center of a closed triangle twist, in which case we have the contraction from the triangle twist plus the contraction from this horizontal line. And that's going to mean that this pleat has 2 grid spacings between the mountain and the valley fold. For a right-handed twist, that's going to be up above on the right-hand side. And all of these other 3 pleats have 1 grid spacing. So the characteristic of a trapezoid twist is this, this crow's foot setup. And I'm actually going to bring back the faint red pen to draw the trapezoid tile. So this is kind of mathematically what has to be true. You need twice as much contraction across this direction to balance out the contraction in these directions. That's maybe going a little too deep into the weeds for beginners, but this is what we're thinking about when I call this a trapezoid twist. I'm talking about the underlying tile. And so we can bring up our mountain folds. Notice we've got a central diamond kind of thing going on here. And when I start laying down my pleats, I notice that this one has that little back and forth, that little leg. So I end up with an extra mountain fold in here and an extra valley fold in here. To get that all to work out. And then we have our double depth pleat, which is connecting at that little leg. And from there, we can press from the top to squash, just like the closed rhombus twist. So here, where the closed rhombus twist had a slit on the back, the closed trapezoid is actually going to come to a single point. So that's another way we can tell them apart. And also, with the rhombus twist, you have 2 pairs of parallel pleats. With the closed trapezoid, you have these 3 single depth pleats and 1 double depth pleat. From here, we actually take a look at the back of this to find our next new twist, the mixed depth rhombus twist, specifically the friendly mixed depth rhombus twist. So this one I'm going to use 12 grid division, or actually no, I think I calculated this out and it'll fit on 8. So if I have, it's always interesting to figure out exactly where you want to put the twist on the paper. Yes. Okay. There we go. It's a bit more information, so it takes a bit more to find it. With this twist, we're going to have double depth pleats and single depth pleats. And we're going to have basically that interaction that we saw with the closed rhombus, where we have our through line going to the pointy corner and the diagonal coming in, except that this time there's going to be two different lines going out to pointy corners, and we're going to have a space between them. And the weird thing about this twist is that the valley folds are on this side. So the mountain fold of one of these double depth pleats is between the mountain and valley of the other double depth pleat. This is a very weird twist. And then our valleys for the single depth pleats are further away from the center like we would expect. And so when this twist is put into place, we end up with this long, skinny setup that often does not really want to have the pleats lay flat, especially on this size of grid. But the key things to notice is, like I pointed out, the mountain fold of one of these double depth pleats is between, on the grid line, in between the mountain and valley of the other. It's true on both sides. And these mountains of the single depth pleats are 1, 2, 3 grid spaces apart. With all of that in place and stabilized, I can press from the top to squash, and it does indeed lay down flat. Hard to believe, but it does work out. And kind of surprisingly, because you would think, hey, we outlined a 1 spacing by 3 spacings parallelogram, but the back is a slit. And it's actually very similar to the slit for the closed rhombus twist. The only difference is that these pleats that are going across the slit are going in different directions. So on here, they're going this way. On here, they're going this way. So that's our 2 of our rhombus twists. And I'm going to be coming back to this mixed depth rhombus. I had mentioned that this is the friendly version because you can actually fold it on its own. We'll come back to the unfriendly version in just a bit. But first, we have another trapezoid twist and another hexagon twist. So this is a 2-fold skinny mixed depth hexagon, and I'll get into exactly what that means. But first, we're going to fold the open trapezoid. So the open trapezoid, I'll use 8 grid divisions. And like the closed trapezoid, it's going to have one line that continues straight all the way through. Unlike the closed trapezoid, we're going to have, well, and it has another direction that attaches, and I'm attaching that at the center point. The closed trapezoid would have the 3rd single depth plate connect at the same point. The open one moves it 1 grid spacing out. And I realized that the way that I've drawn this actually is not a right-handed open trapezoid twist. These would be in opposite order. It's actually the left-handed open trapezoid. So we get to see the left-handed form of one of these twists. And again, because it's a trapezoid, the direction of fold that's kind of on its own, that doesn't have a neighbor in the next grid direction over, is double depth. So with all of that in place, we can curl this around. And I will say the common failure mode for the open trapezoid is getting stuck somewhere here. And to deal with that, we need to open up the space between this kind of bow tie situation. Let all of our single depth pleats lay down, like half of an open hexagon. So you can see points of the puffy hexagon star, and then the double depth pleat kind of seals the deal, and we're able to press from the top to squash. So this is the left-handed open trapezoid. And one of the weird things about this open trapezoid is it's an open twist that does not outline any area. It actually also has a slit on the back. So it can be easy to confuse with a closed rhombus twist with the same slit. These pleats are the same, but this pleat is going in the wrong direction. It would be going this way if it was a left-handed closed trapezoid, or sorry, closed rhombus. And this one is a double depth pleat, which is a dead giveaway. So that's the open trapezoid twist. And then let's get into this stretched out hexagon. So I'm going to grab one of my grids with 12 divisions. And this stretched out hexagon, so I'm just gonna mark the center. This will be kind of the center of my hexagon twist. I'm going to start drawing 2 hexagon outlines on my grid. This is the basis for the twist. We're going to have this be a right-handed twist. And so our mountain folds are going to come out in these directions, and I'll rotate and do the mountain folds exactly the same way on the other side. And you'll notice there's some corners that I did not put mountain folds on. Those are the corners where we're going to have double depth pleats. And functionally, what's going on is if we had a mountain on this corner and we had a valley one space away from this mountain, they would be on the same grid line and cancel each other out. And so that's why we have some corners with no other folds coming to them. So this is basically the setup for 2 open hexagon twists that are fused edge to edge. And then we can go in and set up all of these pleats, making sure we have our double depth pleats as well. And the guiding principle here is that we've got single, single, and double. single, single, double. So that's the order of our pleats. We want to make sure that all of our valley folds are actually on grid lines, and then we can press from the top to squash, just like the open hexagon. So I said towards the beginning that there are 5 hexagon twists. So far we've seen 3. We will be getting to, there's other 2 in the last couple days of patterns. So there's our open hexagon, or sorry, our 2-fold skinny mixed depth open hexagon. It's a long name. The longer the name, the more complicated it is. And here we see the 3x1 parallelogram that I'd pointed out maybe we would expect from the mixed depth rhombus. So we have a hexagon twist that has a parallelogram on the back. Welcome to mixed depth twists. And in the actual pattern, we don't even see the parallelogram because we have twists close enough to it that it's taking away the paper and making more of a funky S or peanut shape. So that's what's going on with this twist. Next up, we have our open trapezoids around closed hexagons and open triangles, but there's something weird. It's tucked into another mixed depth rhombus, but this mixed depth rhombus, besides being left-handed, well, I should say this one is right-handed, this one is left-handed, and they have the exact same shape and orientation. That is very weird, because if I take a mirror image of this, it's not going to rotate and match up with any of these. So it's not quite the same twist. It's actually a unfriendly mixed depth rhombus twist. And the unfriendly mixed depth rhombus, and the easiest way to explain this is actually to modify the friendly one. Oh yeah, Chris, we're getting into some really cool new twists, including some coming up soon that are, well, actually this one, the unfriendly mixed depth rhombus, that are not in the Summer of Twists series. So here I'm holding the friendly mixed depth rhombus. The unfriendly mixed depth rhombus has its valley folds attach at the opposite end of the double length edge. So let me do this from the other side of the paper so we have kind of 2 clean models. And I'll flip all of my folds, so we're working with mountain folds on the side that we're looking at. So right now I'm flipping to the left-handed version of the friendly mixed depth rhombus. And then the unfriendly mixed depth rhombus, instead of having the valley attach here, is going to have the valley attach to the other corner, the valley of the double depth pleat. And I'll go ahead and draw that on both sides. And that means that our direction of the pleat from the other corners, let's see, does that need to change? I would think, okay. No, that's actually going to stay. Oh, okay. we're going to keep the mountain fold coming out of there because there's no way around having the mountain in that direction off of a skinny corner. But instead of the valley being the double depth valley on the other side, the valley is going to come from this side. And what we have here is a right-handed unfriendly. So let's get to the unfriendly part. We already know how the twist will squash, but if it's squashed that way, there is no way for this twist on its own to have the pleats on the other side lay down flat. If this one's layered on top, then this one needs to fold out from under. And that's actually how we get around this problem. We have some other twist cut under and take out some of the stress. So in this case, I would have a twist coming in at least that densely. To be able to get this twist to fold on its own. Well, not on its own, with the help of the other twist. And so that's what makes this rhombus twist unfriendly, because it needs other twists at pretty dense spacing in order to allow the original twist to lay flat. That doesn't mean, however, that you can't fold repeats of this pattern without pre-creasing, because you're always going to have a trapezoid there before you want to fold the mixed depth rhombus. And the unfriendly mixed depth rhombus also shows up the next day with open, so difference between these 2 days, closed versus open hexagon, open versus closed trapezoid. And then you've got the same things on the back, just spaced differently. And for this one, the corner of that mixed depth rhombus can either be above or below the triangle twists. And then moving on to the next day, we have closed triangles and open trapezoids. And those are showing up on both sides, and there's no other twists used. The day after, we do get a new twist. It's our final triangle twist. The closed triangle, the open trapezoid, same things on the other side, and a double depth closed triangle. So this time, and I'll grab an 8 division grid, this time when we have our mountain folds for our closed triangle twist coming in to a single point, which I've put in the center. Now, instead of there being one grid spacing between the mountain and the valley, we're going to have 2. And so this one will set it up just like the regular closed triangle. It'll just have extra grid lines. And the reason to use this double depth triangle is because it's using double depth pleats from trapezoid twists. So I need something that takes in a double depth pleat there, and a triangle was the easiest thing to use. And then with this amount of grid, since I don't have like a whole bunch of extra space, I was helping it get in place by pressing from the top to start, instead of starting by pressing on the pleats. But also, if you want to answer to how to turn a hexagon into a triangle, double depth closed triangle twist on an 8 division grid is one of the answers to that question. And then because it's a closed triangle twist, we do see the closed hole on the back. Continuing onwards. So we've got our double depth closed triangle. Here we're actually putting together closed triangle and open trapezoid twists in another way on both sides of the paper. This one throws in some closed rhombus twists into the mix. And here we have closed hexagon, open trapezoid, closed triangle on this side, and open trapezoid, closed triangle again on the other side. Lots of interesting wraps to get that in place. This one has the exact same twists, but the closed hexagon is on the opposite side. And now we get into some new twists again. So here we have a double depth closed hexagon. You see there's 2 grid spacings per edge of that closed hexagon. Here we have a closed trapezoid twist underneath. I think up until this point we'd only been using right-handed closed trapezoids, and this one's left-handed. And then closed rhombus and open triangle twists. So let's practice that double depth closed hexagon. I'm going to grab a paper with 12 divisions because this does take up a decent amount of grid. We saw already that the closed hexagon was kind of maxing out the 8 division grids. So for a double depth closed hexagon, I'm going to have my 6 mountain folds through the center. And again, like the double depth closed triangle, this double depth closed hexagon is going to be exactly the same thing as the single depth version, just with an extra grid spacing everywhere. And we're going to have our valley folds. In this case, we'll only see them in right-handed form. So I'm definitely doing the right-handed version. And on this size of grid, I am going to recommend folding kind of one corner at a time. And getting that all worked out by the time you get all the way around the paper. And then you can worry a bit more about your valley folds on the next pass around. So in one sense, we had even less paper to work with for this double depth hexagon on the 16 grid divisions than we had on the single depth on 8 divisions. The equivalent would be double depth on 16 divisions. So there's definitely no, okay, let's set up all the plates and do the tower and twist it around on this scale of grid. But it does get you a model that you can play with and see, okay, yes, it does have that closed hole on the back. It does have these properties of 2 grid spaces per edge. It's using only grid lines, and it's super locked into place. So that's the closed double depth hexagon. Then, and that one shows up again in day 24 with open trapezoid and closed rhombus twists. And then for day 25, we do have a new twist on the final day. It's an open double depth hexagon twist, which is not equivalent to a double depth version of the open hexagon. It's not equivalent to just folding more grid lines in an open hexagon twist, is what I'm trying to say. For this one, let me experiment real quick and see if it's going to be at all reasonable. Okay, I think that's going to be flying apart on 12. So I'm going to go to 16 divisions. Like the typical open hexagon twist, and I just put a dot in the center there, our mountain folds are going to be one space away from the center. And I'm drawing this in a right-handed form. Unlike the single depth version of this twist, we are using double depth pleats. And so that star that we found for the single depth version is not going to look the same. So I'm drawing on all of my double depth pleats around this single grid spacing. If we did a direct double depth translation of the open hexagon twist, then there would be 2 grid spacings on this central hexagon. So with the double depth open hexagon twist, as I'm setting it up, I'm paying close attention to how my pleats are working out. And making sure that I have all of the necessary valley folds on the correct grid lines. And you'll notice that this time I'm going into out 1, into out 1, into out 1. So this 2 spaces is due to the double depth pleat. The out 1 is due to the mountain hitting 1 space from the center. These are 2 independent variables. And we'll want to get the hexagon kind of partially collapsed. So I went around to all the edges and kind of smushed them slightly and made sure all of my pleats are happy. And with all of my pleats being happy, I can go around and smooth things more thoroughly. So those are the 14 twists used. Oh, and by the way, here we have a double depth twist. We've got that single open hexagon in the center, single open hexagon on the other side. It's the mixed depth twists where it starts getting confusing, like, hey, I outlined this on the front, why is it not the same thing on the back? It's because the double depth pleat is taking an extra space. So with this guy, it is using up quite a bit more grid than the other twists, but we can see in Coronas, it just has an excellent result. One thing I will say is that you can actually space this 1 space further out, like all of these twists 1 space further out, and the pattern will still work. This is a particularly dense way to do it, and you can see that this hole is bigger than the 1 grid spacing per edge because the trapezoid twists are stealing paper from each edge. So that is going to be the challenging part, the high density on top of the new twist. So those are all of the twists that are used in Advent of Tess this year. We've got our closed, open, double open, and double depth closed triangle twists. We've got our closed, open, two-fold mixed depth skinny, double depth closed, and open, double depth open hexagon twists. We've got our closed, mixed depth friendly and mixed depth unfriendly rhombus twists. Yeah, that's a good point. The friendly mixed depth rhombus does need buddies close, or sorry, the unfriendly mixed depth rhombus does need buddies close by. I guess it's only friendly when it has company, is the way to say that. Yeah, I'm glad you're enjoying the tutorials. And we've got our closed and open trapezoid twists that round out our set of all the twists that we're using in Advent of Tess 2025. So happy folding, everyone. And I look forward to seeing what you fold, even if you're folding like a set of these twists to have as models. Like I'd love to see that. Go ahead and tag me on Instagram. I'm at Gathering Folds. Also on YouTube, but I'm less likely to get the notifications. And then, yeah, I'd love to see what you're folding, especially if my tutorials have helped you to achieve it. So happy folding, everyone, and see you. Oh, and I should say, if you don't want to post things publicly, I also have a Discord server. When you sign up for Advent of Tess or Tessellation Foundations or any of my other courses, you get access to the link to the Discord server, where we have a bunch of people really excited about Advent of Tess and sharing what they're doing, what paper they're using, where they're sourcing paper, if they're, for example, in Europe and don't want to pay the cost of shipping Skytone all the way to Europe. So happy folding, everyone, and see you in the next video.